Hey guys, welcome back to my channel. I hope you guys are doing absolutely great. In this video, we are looking at a problem statement which says combination sum 2. Now this problem statement is an extension of the earlier problem that we have solved, which was called combination sum 1, right? So in case if you have not watched that video, I would highly recommend that you go and watch that video and then come back to this video, because this is basically the extension of that problem statement, right? So what this problem statement says, so basically we are given an input array which is the numeric array basically, and it consists of the number 1 1 2 2 5, and the target sum that is given is 5. Now the condition is, or I can say the constraint is, you can't take multiple instance of a single element from this array, right? You can't take, if I have to make a sum of 5, you can't take 1 5 times, you know. You can't take 2 times and then 1 time. You can't do that, as we have did in earlier problem which says combination sum 1, right? So you have to pick unique elements only, right? So what is the possible output for this input string? So if I write down the output, so if I am standing at 0th position, let me index it down: 0 1 2 3 4, right? So if I am standing at 0th position, which element I can make to make a sum of 5? So I can pick 1 and I can pick 2 and then 2, right? So one combination is 1 2 2, right? Now if I am standing at 1th position, how many combination can I make for sum to be 5? So if I am at 1, I can pick this 1 and I can pick this 2, and I can pick this 2 at index 3. So again I am getting 1 2 2, right? And if I am at position 2, what can I pick? I can pick 5 here, right? So basically, if you notice, we are getting two occurrence of same data set, 1 2 2 1 2 2, right? So we don't really want the repetition in this scenario, so we have to take care of this scenario, right? So how to let's see the program here. Now I have written a pseudocode for the combination sum 1 problem that we have solved earlier. The same thing has been pasted here. If I pull up the old sheet of combination sum 1, so this is the pseudocode that we have written, right? So I have copy pasted this same thing here, nothing different. Now we have to do some subtle changes here so that it works for combination sum 2 problem as well, right? So what are the changes we need to do in this problem? So if you see here, let's go through the program first, just as a refresher. Now this is the index I, and then this is your data set, or you can say data structure, and this is the desired sum we are trying to achieve, right? And we have written a base case which says if I is reaching the nth position and my sum is reaching to 0, I will add this to the result set. Result is what? Result is a list. List is a data type, right? So I am adding to my result set the temp value, and we have two conditions in the logic section. First is to, we can either include the element at ith index, or we can exclude the the element at the ith index. Suppose if I am trying to include the element in the ith index, so I am saying if and only if the element is smaller than the desired sum, I am basically adding it to my temp.add. Basically I'm adding it to the temp variable, right? So, and then I'm calling a recursive function call. In this function call, I am not doing +1 here. If you see, the index is still 1, because we were allowed to take multiple instance of the same element, same index element, right? So this is the place we need to do changes actually. The only difference between the last problem and this problem is that in the last problem we were allowed to take multiple instances of the same element, wherein in this problem statement we are not allowed to take multiple instances of the same element. If I am including one that is located at position 0, I can't take this element again. I have to move my pointer ahead to the 1, right? So there's the change that I have to do. So this line will become like this: function I plus 1 temp, and this will be sum minus array of I, right? This is the change you have to do, and this part remains the same as it is, no changes. Now another thing is that, as I told you, that we are getting a repeated data set, right? So we don't want this. I expect the output to be 1, 2, 2 and 5. That's it. I don't want repetition of dataset in my result. So how can I handle that in that situation? So all my result set are stored in this result variable, right? And the data type of this result variable is list. Now what I can do is, instead of uh, list, I can use set. Now what set does is, set will basically maintain a unique elements in within itself, right? If I insert, suppose the set is of type integer, right? And if I insert 1 2 3 and again I insert 2, then it will only persist one copy of 2. It will not have two instances of 2, right? So this is how set work. It is a part of Java. So yeah, so these are the two modification you have to do, and then you will be you can be able to easily convert combination sum 1 problem into combination sum 2 problem, right? I hope this makes sense to you. I will show you the Java code for this problem statement. Okay guys, so this is a sample Java program for combination sum 2 problem. So let me walk you through this code so that you can understand this in a better terms, right? So basically I have a class called solution as usual, and I have a main block within this class, and I have a function called combination sum 2, right? I have some input data structure, data set, which consists of the values 1 1 2 2 5, which I have already mentioned in the sheet that I have shown you earlier. And I hold a result data structure. If you see here, the data type is set. We have set which consists of list, right? So only unique value will be persisted or maintained in this result data type, right? So coming to the function combination sum 2, it accepts three arguments. First is the index, we call it I, and second is the data structure that we call it as temp, and third is the sum, that is the target sum that we are looking for, right? And here is the base case. This code is similar to combination sum 1, right? You can refer that, it is exactly similar to that. If you look at the base condition here, so if I is greater than equal to data dot length, whenever I reaches the last element of the input string, so in that scenario we will be checking if the sum is 0, right? If the sum is 0, we are adding this temp into our result, main result, right, set. And coming to the logic part here, this portion is when we are including the element for our result set, and this portion is referring when we are excluding the element from our result set, right? So when we are including the element into our result set, what we are saying is, if the data element, yeah, if any of the data element is smaller than the sum that we are expecting, then in that scenario only I will add it to my temp data structure, and then I will call a recursion. Now if you notice, I am moving the pointer of index by 1, right? We don't want to take multiple instances of the same element, that's why we are moving the pointer by 1, right? This is the only difference between the combination sum 1 and combination sum 2, right? You have to notice this. So if this is done, and then we are doing the backtracking, we are basically removing the last entry we have inserted here on line number 21. Whatever we have inserted on line number 21, we are undoing that changes by removing that from our data structure, right? And in the case of what we call is exclusion of the element from our result set, we are just moving on the index plus 1 by plus 1 actually, and then I am passing the temp as it is, and the sum will be as it is. It will not be reduced because we are not including the element at position I in our result set. So this is the basic logic that we already had in combination sum 1 with the subtle change here and here, right? And then in the main method I am calling this combination sum 2 with the 0 index as the initial index. Temp is a data structure that we hold temporary data, and phi is the expected target sum we are looking for, right? And finally I am printing the result, right? Let me quickly run this program. So this is what we are expecting, right? So if I sum it up, 1 plus 2 plus 2 gives me 5, and 5 itself, right? I hope this makes sense to you. This problem was similar to combination sum 1. If you are familiar with combination sum 1 problem, then this should be easy for you to solve it, right? Okay, then see you on next video with some different problem set. Thank you guys.